Hello Gators, this is 2-1 Parallel Lines, Day 2. Let's take a look at a postulate. It says that if a transversal intersects two parallel lines, then same side interior angles are supplementary. Let's remember that a postulate means we accept this without proof. So 1 and 2 are what we call same side interior angles, and these two angles will add up to 180. Let's look at an example how we can use this. Here we have two parallel lines, and the theorem says as long as you have two parallel lines, then these angles have to add up to 180. So that means angle 8 will have to be 125 degrees, because this 55 and 125, 0 carry 1, 8, 1, that would add up to 125 degrees. So that's what this theorem is allowing us to do, is figure out angle 8. Now once we figure out angle 8, then angle 6 will be 125, because those are vertical angles. And then this linear pair here will be 55 degrees. And then these are vertical angles. This is also 55 degrees. This is 55, this will be 55 degrees. This is a linear pair, 125 degrees, 125. So when I have parallel lines and I create these 8 angles, if I know one of the angles, I'll be able to find the other 7. Let's take a look at alternate interior angles theorem. Now this says that if you have two parallel lines, again, we've got parallel lines, we'd like to prove that alternate interior angles are congruent. We like to prove that 1 is congruent to angle 2. So step 1 is the given, and from the last theorem we just had, we know that 2 and 3 are same side interior. So we can write if two lines are parallel, we figured out last thing the postulate said that same side interior angles are supplementary. Okay, and then the next one says angle 1 is supplementary to angle 3. So angle 1 is supplementary to 3. That's from the last chapter. And we know that if two angles are a linear pair, which they are, then they are supplementary. Okay, so I have two supplementary sets here, and they look like they're supplementary to the same angle, and when they're supplementary to the same angle, the buddies are congruent. So the reason is a theorem that we had in the last chapter. If two angles are supplementary to congruent angles, then those angles are congruent. And so that's how we do the proof. Let's take a look at corresponding angles. So again, we have parallel lines, and parallel lines indication is this arrow right here. We'd like to prove that angle 1 and angle 2 are congruent. Angle 1 and angle 2 are what we call corresponding. They're facing the same direction. All right, so step 1 is the given. And from the last proof we just did, we know if two lines are parallel, alternate interior angles are congruent. So if two lines are parallel, alternate interior angles are congruent. And you can see angle 1 and angle 3 are congruent because vertical angles are congruent. And it looks like they are congruent to the same angle, and that's called the transitive property of congruence. And that's how we prove that one. And here's our last proof. We want to show that when we have parallel lines, and again we know we have parallel because of these arrows, and we'd like to prove that alternate exterior angles are congruent. So first step is given, we have parallel lines, and 2 and 3 are corresponding. So anytime if two lines are parallel, we know that corresponding angles are congruent. 1 and 3 are vertical angles, and we know they're congruent. And it looks like these angles are congruent to the same angle, so they must be congruent to each other. And that's the transitive property of congruence. All right. So these are the four things we now know. This first one was our postulate. We didn't prove that. If two lines are parallel, same side interior angles are supplementary. That means 65 and 6 will be supplementary. So that'll force 6 to be 115 degrees. Okay, in order to add up to 180, that would have to be. If two lines are parallel, which we know these are the arrows, then alternate interior angles are congruent. Alternate interior, so that's 65 degrees. These two have to be the congruent, 115 degrees. Alternate exterior angles are congruent, and corresponding angles. Let's do corresponding angles first. 65 and 65, and then 65 and 65. And then we can say alternate exterior angles are congruent, and you can see that. And then here's 115, and here's 115. So with these theorems, we just need one to get to them all, but you can see the relationship is true for all. Okay, let's go ahead and use this theorem to help us figure out what x is, solve for x. First, you have to identify what kind of angles these are, and I can see that they are corresponding angles. So I can see that the two lines are parallel, and I can see that what I want to do with these is make them congruent. So I want to set them equal to each other. 15x plus 8 is equal to 128. Subtract 8 on both sides, and that'll be 120. And then x will be equal to 8. Okay, and that's what x will be equal to. Okay, let's go ahead and use this theorem, see if we can get through the steps. We are told that G is parallel to H, so maybe I can just put that in a color right here. And when I put G and H parallel, then I have this, so that is all the given. As soon as I see those parallel lines, I look at this transversal. Those are the three lines I'm looking at. And when I look at the three lines, 1 and 3 have a name, and they are called corresponding angles. And I know that the theorem says that those are going to be congruent. So I can say 1 is congruent to angle 3. And the reason is if two lines are parallel, corresponding angles are congruent. Now I notice in line 1 I have an angle 3, and in line 2 I have an angle 3. These two angles are congruent to the same angle, so I'm going to say angle 1 is congruent to angle 3, and that's going to be transitive property of equality of congruence. Transitive of congruence. All right, let's go ahead and remind ourselves the slope. I hope you're getting more comfortable. This is going down 3 units, and it's going over, it looks like it's going over 5 units. So the slope is -3 over 5. All right, let's go ahead and write the equation. Number 1, it'd be good to find the slope. And remember, we just did it, down 3 and over 5, so -3 over 5. It's not easy to use this method because I don't know where it's crossing the y-axis, so I'm going to use this one. And so I'm going to use one of my points. I'll use this point 2, 0. Everywhere I see an x, I'm going to put a 2. This should have been a 1 right here. And then this should be a 0. And our slope is -3/5. Let me try again. Okay, -3 over 5. So I'm going to clean it up. Y, and I don't have to say -0, equals -3/5 times x minus 2. And this will be the equation of the line. All right, let's try again. And I can see this slope is 0. Anytime you have a horizontal line, that's a slope of 0. If you want to, we could use this one because I do know where it's crossing the y-axis. So this is going to be 0, the slope is 0, and this is crossing it at 4. So the answer is y is equal to 4, because 0 times anything is just 0. All right, let's try this one. Let's again figure out the slope, and it looks like it's going up 2 over 3, up 2 over 3. I cannot use this method because I do not know where it's crossing. I can use this 2/3 as my slope, and I use this point 2, 1, and this should have been a 1 right here. This is going to be a 2, this is going to be a 1, and I can clean it up. Y minus 1 is equal to 2/3 x minus 2. And that's the end of the screencast.